Hello, in this tutorial we are going to create bar bending schedule for footing. Now footing we have isolated footing, single reinforcement. So let's get started. Now I'm here in the drawing and we have plan over here, we have section over here, and it is clearly mentioned in the section we have bottom reinforcement, mean main bars and the distribution bar. The bars at the bottom is the main bar and bars at the top is the distribution bar. So here in the plan I have draw the main and the distribution bar over here as well, because I want to give you the idea regarding how we can place it in the footing really. So these red bars are basically the main bars and these bars are the distribution bars. Now let's check the detail over here. The footing size is 1000 by 1000. 1300 by 1300 is basically external dimension including PCC, and if we deduct this offset, and offset is total of 150 from 1300, at one end side 150 and at another end side 150, it will become what, 1000, and at this end as well 150 and 150 will give us a total dimension as 1000. So this footing is basically 1000 by 1000 millimeter. Now in which we have to place the reinforcement, the main and the distribution bars. So let's check the detail regarding main and the distribution bars. Main bars we are using 16 mm dia, 150 center to center, and for distribution bar we are using 12 mm dia, T12 mean 12 mm dia, 200 center to center. So this is basically main and the distribution bars. If in your case it is double reinforcement, no problem. As we will do here in the bottom reinforcement, you can find out the top reinforcement as well with the same method. So let's go into the Excel and find out it over here. First of all, we will find out the main bar, then we will go for the distribution bar. Now this is basically the BBS Excel sheet. We have already explained this sheet to you, and with this I have give you the example regarding how we can do the formatting over here. Hope you understand that particular video. Both of those videos are very important. So first of all, you need to understand that how we can create this sheet and how we can do the formatting in this sheet and different formulas over here as well. Now next to it is time to create BBS. So we'll simply go and start right from this position. Serial number as 1 and member is what? This is basically a foundation isolated footing F1. You can give any of the name over here according to your foundation. Now length of the foundation 1000 mm, we have checked it. Breadth of the foundation 1000, and what about the height of the foundation or thickness of the foundation? So it is mentioned over here, it is total of 400 millimeter right from this position up till here. Now if it is double reinforcement, then thickness matters because we need to find out the chair bar and some other things. Next to it, bar details mean particular placing of bar. So these are main bars. First of all, we will find out the main bars. Next, spacing of the bar as well. So spacing is mentioned over here. For the main bars we are using 150 center to center. Next to it, we need to create a shape for this bar, and in section you can see we have two bends over here and the straight shape. So in order to create shape, we need to go into the font panel, and this is basically draw border option. We have different options to draw the border, and we will simply go here in draw border option, this one. And what I'll do, I'll create shape over here. Sorry, again I'll click over here, then this and this as well. So we have two bends over here and the straight shape. Now remember one thing, here we have two bends, mean two 90-degree bends. So we need to do the deductions as well for the bend. And if you have not attended the BBS basic training, that training is also very important. If you are beginner, then you need to must attend that particular training first and come here. Without that, it is very difficult to understand these things. Now for bend deduction, what is the value? Definitely for 90-degree bend we have 2D, the bend deduction. So we have two bends over here, this one and this one. So equal to two bends multiplied by 2 into dia bar. So dia is over here. I'll select this cell because we will put dia over here. And when we will put the dia over here, it will give the value over here for the bend deduction. Next to it, we do not have any kind of other bend like 135 or 180 degree, but we have bend length over here. So for 90-degree bend, let me go here, and we are using what? We are using 12 plus 4, 16 into dia bar for the 90-degree bend, this one. So I'll simply go here, and it is equal to 16 into dia bar. And what is the dia? Dia is 16 mm in the main steel. Next to it, concrete cover in the foundation. We need to check this as well. Go into the journal notes, and we have mentioned here foundation 50 mm we are using. So journal notes are very important. And then we need to find out the number of bars. So in order to find out number of bars, what is the formula? Yes, span divided by spacing plus 1. So what will be the span for the main bars? Remember, span for the main bars will be the length of our foundation. Length of our foundation is placing span. Let me just show you over here. Because of this, I have just draw this one. These red bars are the main bars, and placing span is this span. Let's put this is length. So placing span of the main bars, remember this one is length, and cutting span of main bar will be width. Both of these span are different. Placing span is different. This is placing span, and this is cutting span. So placing span is length. So in order to find out number of bars, we need to first find out the placing span. So in this regard, we have the same length and the breadth are same, but we will take length divided by spacing is over here, plus 1 will give us number of bars. Hit enter. So we need here what? 7.66 bars. So here we have the values in the decimal. We do not need the decimal value, whether we need 7 bars or the 8 bars. So value is more than 0.50, so we will round up this one in order to convert it into 8. So I'll go here, round up, start the bracket, and then comma, close the bracket, hit enter. So we need what? Total of 8 bars. Multiply by number of members. How many foundation we have the same F1? So simply go here, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13 foundations we have. So in one shot we can find out all of these. But if in your case you have F1, F2, F3, you need to find out them individually. Remember. So multiply by total numbers will be equal to what? Number of bars multiplied by number of members. Hit enter. Now next to it, we need to find out the total length, and in order to find out total length, first of all we need to find out the cut length of bar. Now remember one thing, the total length, hit enter, equal to what? Number of bars multiplied by total length, and in order to find out total length, first of all we need to find out the cut length of bar. Now remember one thing, these bends we have find out them already over here. 256 mm, it is equal to this one as well. Now we need to find out this horizontal length. And what about this one? All we need to do is we need to find out this length right from this position up till here. The footing length, footing breadth is 1000 mm. From this we need to deduct concrete cover from both ends. This is what? This is simple. So in main bars, the cutting span is what? The breadth. So we will take breadth over here minus concrete cover from both ends. And this is basically the cut length. And let me move it from both ends. The breadth. So we will take breadth over here minus concrete cover from both ends. And this is basically the cut length. And let me move it up to this position or then up to this. Now in order to find out total length, what will the formula? It will be equal to cut length. So this one plus this one plus this one. And then next to it we need to deduct the bends as well. This is the bend deduction. Multiply it with total numbers and then divide it on 1000. Okay, so multiply it with the total numbers and divide it on 1000 in order to convert it into meter. Hit enter. So this is basically the total length for all of these foundations. The main bar I am talking about in F1 140.192. Now next and the last, we need to find out the distribution bars as well. Number 2, then this data is sent, so copy this one, simply paste it over here, Ctrl plus V, and now it is time to find out the distribution bars. Next to it, we need to add here the spacing between two bars. So let's check this one. In the section it is mentioned we are using a 200 spacing for the distribution bar. 200. Next to it, what we need to do is we need to find out first we need to create a shape for this bar. So this is again the same shape in the distribution bars as well. We have two bends over here. So next to it, we need to add here the bend direction. Now for bend direction, it is equal to, we have two bends into 2 into dia bar, because this is 90-degree bend. So dia is over here. Next to it, we do not have any kind of other bend. We have bend at the revolvement length, that is 16 into d. What? 16 into d. So equal to 16 into dia is over here. And what is the dia here in the distribution bar? Yes, 12 mm. So according to that, you can see the total values over here as well. Concrete cover in the foundation is 50 mm. And now it is time to find out the number of distribution bars will be equal to span divided by spacing plus 1. Now in distribution bars, placing span is breadth of our foundation. Remember this one. Span divided by spacing is over here. Plus 1 will give us number of bars. Hit enter. So we need total of 6 bars over here in one foundation for the distribution. And then total numbers will be equal to, we will have a number of bars. Sorry, this is number of members. So number of bars multiplied by number of members, we have 13 foundations over here. Multiplied by total numbers will be equal to number of bars multiplied by, we have number of members over here. Hit enter. Next to it, we need to find out the total length. And in order to find out total length, first of all, we need to find out the cut length. Now let's find out the cut length over here. This is same. Remember one thing over here. It is very important to understand the placing. So cutting span for the distribution bar will be length of our foundation. These things are very important to understand. Cutting span for the distribution bars is basically length of our foundation, and placing span is basically breadth of our foundation. And for main bar, cutting span is basically breadth of our foundation and placing span is length of our foundation. These things are very important to understand. So this is basically concrete cover from both ends. So it is length, it is equal to length minus concrete cover from both ends. So concrete cover is where? Now next to it, what we need to do is we need to just find out this one as well, do both of these bends. This is deduction, this basically, and this as well, and hit enter. Now at last we need to find out the total length, and total length will be equal to, we know cut length, so this is equal to this one plus we have this one plus this one as well, minus we need to do the bend deduction, and then next we need to multiply it with total numbers. I'll go here and I'll move it toward this cell and divide it on 1000 in order to convert it into meter. Hit enter. So this is basically the total length for the distribution bars, and this is basically the process how we can create bar bending schedule for the footing. And here we have what the isolated footing. Double reinforcement, simply with the same method you can find out the top reinforcement as well.